Hello guys, I'm welcoming you to my channel, and it's Mathphobia, and on this channel we are going to learn how to solve some math questions together. Right, so fast forward, in this first video we are going to learn how to integrate the secant of x with respect to x. So in order to do this, we have to introduce some expression into the question that we have over there. So we have to find the integral of secant of x with respect to x. Now before we do that, we have to introduce an expression, and that expression is secant of x plus tangent of x. So in order to introduce this expression into this, we should make it in a way that will not change the value of the secant of x. What I mean is that when we are to introduce that expression into this, it shouldn't change secant of x after we simplify it again. So we get secant of x. That expression we have to introduce is secant of x plus the tangent of x. Now because we've introduced this expression into it, we have to divide it, because right now it's just multiplying. If we are to leave it like this, it will change this whole expression. It will not be the same thing as the secant of x. So we divide it by that same expression, which is secant of x plus the tangent of x with respect to x. So you can see that if you have to cancel them out, we'll still be left with the secant of x. Now we do substitution. In integration, the very popular substitution that we use is for u. So we let u equals secant of x plus tangent of x. Then we differentiate it. The reason why we differentiate this is that we are introducing a new constant, a new variable, which is u. So we are no more integrating with respect to x by respect to u. So we have to differentiate u. So if you differentiate u with respect to x, we get du dx equals, if you have to differentiate secant of x, we arrive at secant of x multiplying tan x, and then plus, if you have to differentiate tan x, we get secant square x. Now because we are having a new variable u, we are no more integrating with respect to x, so the dx should change to du. So in that case, we have to make du the subject. So dx, we are making dx the subject, so dx will be equal to du over secant x tan x plus sec square x, right? So doing a substitution, get secant of x. We represented the whole of this with u, right? So it will be secant of x multiplying u over u, but the u over u will cancel out, so we don't have to rewrite it again. But then the dx is no more dx, but it's du over the whole of this expression. So we represent it with its new expression, which is secant x tan x plus sec square x, right? You can factor out sec x from the expression of the denominator, so that gives us u over secant of x out. We are left with tan x plus secant of x. So you can see that this two will be able to cancel out, but then tan x plus secant of x is u. So we will now have u over u, which is the same thing as the integral of 1 over u with respect to u. And then the integral of 1 over u with respect to u is the natural log of the absolute value of u plus a constant c. By u, as we already know, is secant x plus tan x. This implies that the integral of the secant of x with respect to x will be equal to the natural log of sec x plus tangent of x plus constant c, and that will be our final answer. So thank you for watching, and then I'll see you in my next video. Please do like and subscribe. Thank you.